Welcome to RemedialOne YouTube channel. In this video, we want to look at question number 7 of Wassce 2022 elective mass. Let's start. A body of mass 5 kg is suspended by inextensible string from a point O and is pulled by a horizontal force F until the angle of inclination of the string to the vertical is 30 degrees. We are to calculate A, tension in the string, and then B, the value of the force F. And one thing about this type of question is, if you have to draw the diagram, you need to draw. So let's look at how the diagram is drawn. So a body of mass 5 kg is suspended by inextensible string at point O. So this is the point O, this is the string, and then there is the tension in the string, which is T. And the angle of inclination is to the vertical. There are times that it will be horizontal. If it is horizontal, and let's draw the horizontal line, the angle of inclination is to the horizontal, then the angle will come this way. And then this is the weight, 5 kg. So you convert it, you multiply it by 10, making 50 newtons. And then there is a force which pulling the weight horizontally. Yes. Now there are two ways of solving this question. We will look at both methods. So the first one, let's use Lami's theorem. We need to redraw this diagram. Now looking at this carefully, if here is 30 degrees, then here will be 60. This angle will be 60. Then alternate angle. So this angle too will be 60. If this angle is 60, then here will be 120 degrees. As adjacent angles, angle on a straight line, because this angle is 90. Then this is 90. 90 plus 60 is 150. So let's draw the diagram. This is 120 degrees. This is 90. Then this becomes 150 degrees. Then the tension here, F. And then this is the weight. That is 50 newtons. By Lami's theorem, T over sine 90 degrees equal to 50 over sine 120, which is also equal to F over 150. Let me show you what happened. So the force here over the sine of the angle of C to the force, the tension here over the angle of C to the tension, and then 50 over sine 120 angle of C to the weight. So to find T, let's take sine T over sine 90 degrees is equal to 50 over sine 120. And we want to find T. T sine 120 will be equal to 50 sine 90 equal to sine 90 is 1. So 1 times 50, half 50 over sine 120 will be equal to 50 times 120 is 0.8660. Our T will be equal to 57.7 Newton. So let's find F using 50 on sine 120, which is equal to F over sine 150. Realize that when you cross multiply, F sine 120 will be equal to 50 times, and this F will be equal to 150 over sine 120. Sine 150 is half, so we have 50 times 0.5 over 0.8660. So we have 25 over 0.8660, and this to be equal to 29.9, so that is our F. So let's see how the scoring will be done for this method. Okay, according to the scheme, when we're able to draw the diagram, we'll be given B1, and if there is no diagram, it means that all the workings will be 0. Care must be taken. If you have a question which involves diagram, even though you were not asked to draw the diagram, drawing it will get you a mark. If the drawing is not there, you lose everything. Be marked for that. Now, in finding, first of all, T, you have M1 for finding T, then the answer is A1. Let's come to, there is another M1 here for finding the T. For the second one, F. Finding F, we have M1, then correct answer for F to get A1. The total 6. Let's look at the alternate method. The second method, you need to resolve the forces into component form. So let me draw this line here, vertical line. We know bearings are measured from positive y-axis this way. So we are going to resolve F into component form, the weight into component form, and then the tension in component form. So starting from here, this angle will be 90 degrees. And then up to this point will be 180. Up to this point, 270 plus 60, which will be 330. So resolving these forces into component form and equating it to 0, y is 0, because the system is in equilibrium. So we have f sine 90 degrees, then f cos 90 degrees, plus 50 sine 180 degrees, and then 50 cos 180 degrees. Then the tension will be, as I told you, this is 270. So 270 plus 60 will be 330. So we have t sine 330, then t cos 330. All this is equal to 0. And why this form? Now when you have the angle theta, and then the magnitude of the force, then resolving force to component form, the sine of the given angle time, and then the cos of the given angle. That is the simple formula that I use here. You can also resolve it in the other way around. So simplifying, we have f sine 90 is 1, so we have f0 equals 90 is 0. Sine 180 is 0, so we have 0. Then this is minus 1, so minus 50, plus minus 0.5 t, and then 0.8660 t, and all go to 0, 0. So when we simplify the left hand side, we have f minus 0.5 t, then 0.866 t minus 50 is equal to 0, 0. By equality of vectors, we can say that f minus 0.5 t will be equal to 0. This implies that f will be equal to 0.5 t. Then the second within y component, we have 0.866 t minus 50 is equal to the y is 0. So 0.866 t equal to 50. Divide both sides by 0.866. Our t is equal to, when we divide, we are getting 57.7 Newton. And then we said that f is equal to 0.5 t. So knowing the value of t, our f will be equal to 0.5 times 57.7. Now when you simplify and run it to one decimal place, we have 29.9 newtons. So let's see how we are going to score this also. Once again, you need to draw the diagram. Drawing the diagram, you have B1. If there is no diagram, it means that the candidate is not going to get any marks from this session, irrespective of the answer being correct. So if the answer, the calculation is correct, and then there is no diagram, person loses all the marks at stake here. So after that, setting up this equation, knowing that if the system is in equilibrium, then all the forces, sum of all the forces or the resultant force is equal to 0. So M1 for that. And finding T as M1, then getting the answer correct, 57.7, we have A1. Finding the F, that's the force, horizontal force, is M1, then the correct answer is A1. Total 6 in all. Viewers, thank you very much for watching this